The Earth is round. This is not a debate, it is a scientific fact proven time and time again, yet the idea of a flat Earth persists. Why? Perhaps some find comfort in a simpler, smaller world. Maybe it feels rebellious to challenge accepted knowledge. Whatever the reason, it is crucial to ground ourselves in reality. We must understand why the flat Earth theory is wrong. We must not be afraid to confront misinformation with scientific truth. It's time to explore the evidence and understand why believing in a flat Earth simply doesn't hold up to the facts. Let's embark on a journey of discovery, guided by science and reason. Flat Earthers envision our planet as a disk, often with Antarctica as a giant ice wall surrounding the edge. The sun and moon, small nearby objects circling above. Gravity, an illusion, they say. They claim that NASA and other space agencies are part of a grand conspiracy, fabricating images of a spherical Earth. They dismiss countless scientific studies and observations as part of this elaborate hoax. But how can we explain the wealth of evidence that contradicts this view? We need to delve into the scientific explanations and see why the flat Earth theory falls apart. For starters, we have pictures. Satellites and astronauts have captured images of Earth from space, clearly showing its spherical shape. These images are not illusions, they are real, tangible proof. Then there's gravity. Gravity pulls everything towards the center of a mass. On a spherical Earth, this means we all experience a downward pull regardless of location. A flat Earth model cannot account for this consistent universal force. Ships sailing over the horizon don't just disappear. They gradually vanish hull first, mast last. This happens because the Earth curves away from the observer. These are just a few examples. The evidence for a spherical Earth is overwhelming and easily verifiable. You don't need to be a scientist to prove the Earth is round. Simple observations and experiments can reveal the truth. Ever notice how the length of shadows changes throughout the day? This is due to the Earth's curvature and the sun's changing position in the sky. On a flat Earth, shadow patterns would be very different. Another experiment: call a friend who lives far away. When the sun is high in the sky for you, it might be setting for them. On a flat Earth, you would always be able to see the sun. Engage with the world around you. Observe, question, and test your assumptions. You'll find that reality often aligns with scientific understanding. The flat Earth theory is a reminder that blind belief can be dangerous. It's easy to accept what we're told, especially if it confirms our existing worldview. But true knowledge comes from questioning, from seeking evidence, and from being open to changing our minds. Don't be afraid to challenge ideas, even those that seem widely accepted. Ask for proof, look for inconsistencies, and demand evidence. This process of critical thinking is essential for navigating a world awash in information. Remember, questioning isn't disrespectful. It's the foundation of scientific progress. It's how we separate fact from fiction and build a better understanding of our universe. Section 6. The Scientific Method, Our Path to Knowledge. The scientific method is not about dogma or blind faith. It's a systematic way of exploring the world, testing hypotheses, and refining our understanding based on evidence. It values skepticism and encourages rigorous testing and peer review. Scientists don't just accept ideas because they sound good. They design experiments, collect data, and analyze results. They share their findings with other scientists, who then try to replicate and verify their work. This process of constant questioning and verification is what makes science such a powerful tool for understanding the universe. It's a self-correcting system that strives for accuracy and objectivity. Section 7. Don't just believe, observe, and discover. The beauty of science is that it's accessible to everyone. You don't need a lab coat or a fancy degree to engage with the natural world. Observe the stars, study the patterns of nature, and question the world around you. Experiment with light and shadows. Research the phases of the moon. Learn about physics and astronomy. The more you explore, the more you'll appreciate the elegance and complexity of our universe. Remember, knowledge is empowering. It allows us to make informed decisions, to critically evaluate information, and to appreciate the wonders of the cosmos. Section 8. The Beauty of Seeking Truth. Seeking truth through evidence and scientific inquiry is not just about debunking myths like the flat Earth. It's about embracing a mindset of curiosity, wonder, and a thirst for knowledge. It's about understanding our place in the vast universe and appreciating the interconnectedness of all things. It's about using knowledge to solve problems, to improve our lives, and to create a better future for all. When we embrace a scientific worldview, we open ourselves up to a universe of possibilities. We become lifelong learners, constantly seeking new knowledge and understanding. Section 9. Embrace curiosity, explore our universe. The universe is full of mysteries, waiting to be unraveled. Let's approach these mysteries with open minds, guided by reason and evidence. Let's celebrate the spirit of scientific inquiry and the joy of discovery. Instead of clinging to outdated and disproven theories like the flat Earth, let's embrace the vastness and wonder of the real universe. Let's explore, question, and never stop seeking the truth. Remember, the universe is our classroom. Let's step outside, look up at the stars, and never stop learning.